welcome to the Math 159 Gould Chapter 6, Section 3 video about the binomial model. Alright, so unlike last time when we were talking about the normal model, the binomial model is a discrete model, which means that it deals with counts. So you might recall that the normal model was a continuous model. It dealt with things which were measured. So this is dealt with things that are counted. And in particular, how we're going to think about this is that the model counts or predicts the probability of a certain number of successes out of, oops, I didn't do that right, out of a fixed number of trials. Okay, so I'm going to give you some rules that will help you determine whether the binomial model is appropriate or not. And there are 4 rules. So whenever you're doing the binomial model, you need a fixed number of trials, which we'll denote with the number n. So ahead of time, you have to say, look, we're going to repeat some process a particular number of times. That number is n. For this model, there are only 2 outcomes: success and failure. So you can't have some other sort of outcome. You have to think of whatever occurs as being a success or being a failure. So it's called a binary outcome. The variable we'll use to track the number of successes is x. And that is what we're trying to predict or calculate the probability of. Very importantly, there is a fixed probability of success, which we will denote with the letter p. Actually, fixed probability of success and failure. So p is the probability of success. You might ask, why are both fixed? Well, your probability of failure is 1 minus your probability of success. We usually call the probability of failure q. Okay. And then finally, the trials are independent. So what that means is that the success or failure of one trial has no effect on the success or failure of another trial. So a very common thing here would be like flipping a coin. If success is getting a heads, one second. So what do I mean by the trials are independent? Well, I mean that they have no effect on each other. For instance, if you're talking about flipping a coin, success could be heads and failure could be tails. It doesn't matter which one is which. You just need to determine what's a success for you. So if success is heads and failure is tails, getting a heads on one flip really in any meaningful sense doesn't really influence what you'll get on the next flip of the coin. Similar things would be like genders of a baby. Having a male child for one pregnancy doesn't in any way influence whether the next child will be male or female, and so on. Lots of things are independent, but not all things are. You have to be very careful about this. Okay, cool. So we have our 4 probabilities. And now let me show you. So what we're interested in calculating now is what's the probability that I get 5 successes? And then you have to specify everything else. So for instance, you could say, okay, whatever I'm doing, I'm going to take 20 trials at it. So let's say we're flipping a coin. So let's say our experiment is flipping a coin. Success equals heads, which means that the probability of success is 50%. And let's say we do it 20 times. Okay, so why is this a binomial experiment? Well, we have a fixed number of trials. We're going to do 20 flips. The probability of success is the same each time. There's only 2 outcomes, either heads or tails, success or failure. And the trials are definitely independent. So we're interested in calculating something like, hey, what's the probability that 5 of those flips are successes, whereas the rest of them, the 15, are failures? So we're going to go to StatCrunch to look at this, to calculate this. Okay, so here I'm at StatCrunch. We're going to use a thing similar to what we did with the normal distribution. We'll go stat we'll go to calculators, and then we'll, instead of going to normal, we'll go to binomial, which is the second one. Okay, so you have to set everything up from the numbers that are given. Notice there's a place to input the number of trials right here, so we'll go n equals 20. Our probability of success equals 0.5. And then now what you need to do is, you can see where it says probability x less than or equal to 5. Depending upon what you're calculating, you'll put less than, greater than, or in this case we want equals, so we get probability x equals 5. So what this is telling us is that there's about a 1.4% chance of getting 5 heads out of 20 trials. And what I want to show you here is that here, right here, oh, it's not letting me highlight it. So, but you can see there's a 5 on the horizontal axis. You can see that it has highlighted the 5. If we change that to, say, 10, click compute, you can see that the 10 is highlighted now. There's about a 17% chance, 17.6% chance of getting exactly 10 heads out of 20 flips. But if you look at the distribution, now that the 10 is highlighted, you can see that the mode right there, you can see that the 10 is the mode, and you look at the right tail and the left tail, that this is a symmetric distribution. And one of the things that we'll end up discussing later is that in certain cases the binomial distribution actually looks a lot like the normal distribution. You can actually see that in this case. So let's go back over to the notes. Oops. Okay, there we go. And we have a question now. Why does the binomial look like the normal distribution? And does it always look like this? The answer is no. And you can change the shape of the binomial distribution. Binomial. By changing the probability of success. So we're going to go over StatCrunch and look at that. So let me switch us back. Okay, so here, remember that the probability of success is a number between 0 and 1. 0.5 is exactly in the middle, and the binomial distribution ends up being symmetric in that case. So if we deviate away from 0.5, let's say to go to 0.2, we'll click compute, you can see that our distribution changes. The mode is at about 4. I've highlighted the mode, it's in red. You can see that's the high point, and you can see that it's a right-tailed distribution because the range is from 4 to 12 as opposed to 4 to 0. So interesting fact, if you decrease the probability of success to a certain point, you get a right-tailed distribution. The same thing happens, well, the opposite happens if you increase the probability of success. So I'm going to put p equals 0.8. It's a number closer to 1 on the right-hand side. You can see now that the mode is about 16. I've highlighted it, right? You can see that it's the highest one, and you can see that it's now a left-tailed distribution. And we'll discuss this more in the future as to why this happens. So this is the end of the first video on the binomial distribution.